Hi friends, welcome to Unit 4B Day 3. We're going to talk about angle bisectors. Now remember, a bisector is a special part of cutting something. When you bisect something, you cut it into half, two equal pieces. So we're going to be using that idea with cutting something in half or two equal pieces a lot for this particular section. So here we're starting with angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant So it is equidistant or equidistant from two sides, of the angle. So here I have ray AD bisecting angle BAC. So that means that DB is perpendicular to AB, and you can kind of see the right angle mark to show that. And that DC is perpendicular to AC. So then I know that BD, it's a terrible B, that BD is equal to DC. Oops, DC, there we go. So that these two segments are congruent and the measures are equal. If a point, and we go the other way around as well. So what we're talking about is if a point on the interior angle is equidistant from the sides of the angle. So now we're just, remember the converse is when you just flip your hypothesis and conclusion. So here we're just flipping our two statements. So we're saying that now these two segments are equidistant, and since they're equidistant, then it is on, so we say it is on or it lies on, it is on the angle bisector. And it is the point. So the point, that part right there. Similarly, so if these parts are perpendicular and that these two lengths are the same, then what we know is that ray AD bisects angle BAC. So you can see that it kind of flips what we said from here earlier. It kind of flips that with the converse as well. So same idea. So here's your congruency arcs. Whenever you have congruency arcs that close, you offset them so that they don't look like one entire congruency arc. And that's because when we talk about one entire congruency arc that goes between both, then it's saying that it's congruent to something else entirely. So that's why we offset those, so that way one's kind of farther back than the other. So we're going to use the diagram to find the measure. And what we want to know is we want to find, for this first one, we find the length of A to D. Now because I have these congruency marks, I have the congruency arcs here, and that these are perpendicular. So this satisfies the angle bisector theorem. So this actually satisfies this first one. A good way to tell is, does it fit without the red markings? So this one fits this scenario. So that means I know that length of DC, so the length of DC is going to be the same as the length from A to D, and we're actually trying to find the length of A to D. So I'm going to put AD is equal to DC, and I know that AD then is equal to 19. We're not putting labels at the end of these. This is we're talking about length. We're talking about some sort of measurement. In science, they would actually really want you to put some sort of units. We don't have a measurement. Like we're not putting a measurement with this. So if you don't know, then you would just put units. For this next one, it says find the angle measure of EFH. This one fits your converse theorem. So I know that these two are congruent here. I'm actually going to mark that. I should have marked this on the other one too, like that. So I know that the angle of, let's see, E, F, and H is going to be, so the measurement of angle EFH is going to be equal to the measurement of angle, let's see, let's go GFH. I know the measure of angle GFH is equal to 28 degrees. So I know the measure of angle FH is equal to 28 degrees. Now, someone wants to know the measurement of angle JKL. So that's this part, the entirety of the angle. Again, we have this perpendicular part, and we have that these two are congruent. Even though it doesn't have the congruency marks, it tells us the measurements of these. So this is another example of the converse. So with that being said, I know that this here and this here are the same. So I know that the measure of angle JKL, I'm going to go about this a different way. I'm going to say that this is equal to twice or 2 times the measurement of angle, let's see, let's go LKM. Oops. One letter ahead. LKM. There we go. So then that means the measure of angle JKL is equal to 2 times 43 degrees. And I know that 2 times 43 degrees is 86 degrees. So the measurement of angle JKL is 86 degrees. And then here it says, can you conclude? So now we're going a different route. We're asking, can we conclude that this is that this ray bisects it? And it says explain. So again, we got to be pretty thorough if we're going to talk about, like, you know, if it doesn't, or if it does, or if it doesn't. So for this first one, again, what you want to do is just go back and check from this first part, either of these two, without my red showing, does it fit one of those two examples visually? And that is a good way to just kind of get that right away. Just visually, does it match either of the two without the red? So here, I know that these two parts are perpendicular, but I don't know the lengths of A to D, so I can't conclude. So no, I can't conclude. So I don't know if is AD equal to CD. If it is, if those two are congruent, then it would be an angle bisector, but it's not. Similarly with this one, I know that the lengths of these are congruent, but I don't know if these are perpendicular or not. So I'm missing, so no. So for this one, it's fitting into this part here. I don't know if I have the perpendicular parts there, or if we have right angles. So what I'm going to do is AB perpendicular, so segment AB perpendicular to segment AD. And remember, you need both, is segment BC perpendicular to segment CD. So I'm missing that as well. For this last one, I have everything fulfilled. So yes, and remember, this is off of your converse of the angle bisector theorem. Again, you're looking for everything that doesn't have that markings, that red markings. So yes, this is the converse of the angle bisector theorem. Now we have finding the value of x. For this to be true, that means I have to have enough information to know that these two are congruent. So here what we know is that these two measurements are the same, because this is an angle bisector. If it's the same, then I can set them equal to each other and solve. So I'm going to go ahead and do that. So I have 5x minus 2 is equal to 4x plus 5. At this point, if you want to check your algebra, go ahead and pause the video. Anytime that we get to this point, feel free to pause the video, check your algebra, see if you're doing the algebra right. It's a good way to just, make sure that you're on top of your algebra skills. So it's something that I would do also if we were face-to-face. So I have x minus 2 equals 5. I'm going to add 2, and I get x equals 7. Always make sure that you answer what it's asking. It says find the value of x, find the value of x. These two are also congruent. So I'm going to set them equal to each other and then solve. 8x minus 9. And as I mentioned in my previous video that I recorded, I always subtract the smaller of the two coefficients to make my life easier. I'm going to add 9. So I get 12 equals 4x. Divide by 4. You get x equals 3. And then for this one here as well, set them equal to each other. So each time we're satisfying either the angle bisector theorem or the converse. So for this one, we're satisfying the converse, and then for the other two, it's the angle bisector theorem. Again, set them equal to each other and then solve. I'm not putting down, I normally put down like AB equals CD or something like that. I'm not doing that because there's no markings on this. It doesn't say like what the different points are. So that's why I'm not including that. But I normally do. 7, add 17. So I get 3x equals 24. Divide by 3 and you get x equals 8. A lot of students go through this last part incorrectly. We actually talk about this. It says, can you find the value of x? It doesn't say find the value of x. It says, can you find the value of x? And then it says explain. Again, this is looking at if it satisfies the converse of the angle bisector theorem or if it satisfies the angle bisector theorem. So again, going back to the front, does it have everything it needs? If it has angle measurement marks showing that it's congruent and it shows that two parts are perpendicular, can I find the value of x? And the answer is yes. I actually know that x equals 9. Yes. I don't want to say that x equals 9. It does not say to find the value of x. It just says, can you? So yes, the explanation is, this is the angle bisector theorem. It does not say to find the value of x. I'm not going to do it. Don't do more work than is necessary. For 11, I am missing that these two are perpendicular. So no, so I'm just going to actually put that. I am missing perpendicular marks. No, I am missing the perpendicular part. And that's for the, in this case, this would be for the converse of the angle bisector theorem. Then this last one, it has the perpendicular in the wrong spot. So this, no, this is missing, oh, I put is twice. This is missing all the parts of angle bisector theorem. It doesn't have any part of it. It has the perpendicular mark, but it's in the wrong spot. All right, friends, thank you for joining me today in these notes. I hope you have a wonderful day.